Right. Okay. So what is given is we know CA2 and we know alpha 2. These are the exit velocity triangles. So let us quickly go to the exit velocity triangle and see where we know the data. We know CA2 and we know alpha 2. And what are the components of CA2? CW2 and CF2. CW2 and CF2 you can find because we know CA2 and alpha 2. So let us find from the exit velocity triangles CA2, CW2 and CF2. CW2 is CA2 cos alpha 2, which is the horizontal component, and CA2 is 85 cos 80 degrees. This turns out to be so many meters per second. Meter per second, and CF2 is CA2 sin alpha 2. This is equal to 85 sin 80 degrees. This turns out to be 83.71 meter per second. Okay. Now, these two components can be found. From this data, very importantly, we have to find beta. Now, beta is the angle made by CR2. Okay. So, we have to link this data and find CR2. So, let us go to the velocity triangle and focus on CR2. CR2 is like this. This is the blade speed. So, I just focus on the components of CR2. This angle is beta 2. Okay. Now, come with me to the velocity triangle. This is CR2. This orange line is CR2. And its horizontal component is the whole thing. Okay. Now this whole thing can be written as CW2, which is the horizontal component of CA2, plus the white line, which is U. Correct. This orange has a horizontal component, one orange part, one pink part, plus one white part. The pink part is same as CW2. The white part is nothing but U. So this can be written as CW2 plus U from the figure. Again, in this figure, this orange has a vertical component which is the pink part. This is CF2. So this length is CF2 from the figure. Now we already know CW2 and CF2. We already are given the blade speed U. So all these clear. This length is completely known. This length is completely known. This is the hypotenuse of the triangle. So the hypotenuse can be found from Pythagoras theorem. And because these two lengths are known, from trigonometry you can find what is beta. So first use Pythagoras theorem. You can write CR2 as square root of this square CW2 plus U square plus this square CF2 square. You substitute the data, root of 14.76 plus U is 150 square plus CF2 square 83.71, and then you get the answer as CR2 equal to 184.81 meters per second. Once this is found, you can find what is beta 2. So from trigonometry, tan beta 2 is equal to opposite, which is CF2, divided by adjacent, which is CW2 plus U2. So now beta 2, and this you can substitute. CF2 is 83.71 divided by CW2 14.76 plus 150. Invert the tan, and then you are going to get beta 2 to be equal to 26 degrees or 26.94 degrees. This is beta 2. Now one data is found. We found beta 1 is equal to beta 2. Both are equal to 26.94 degrees. So let me revise so far. From this given data, one vector and its inclination are given. the CA2 and alpha 2 are one complete pair for this vector. From this data, go to that triangle and find its components. Its components are CW2 and CF2. From this, we are finding the components of CR2. CR2 has a horizontal component of CW2 plus U and vertical component same as CF2. So because these two components are known, this vector itself can be found, its inclination can also be found. Use Pythagoras theorem and basic trigonometry, you can find this. So far we have done that. Now, because you know CR2 and you are given CR2 equal to 0.82 CR1, you are given the blade velocity coefficient. So because you are given CR2 equal to 0.82 CR1, you have found CR2, you can find CR1. So rearrange, CR1 is CR2 divided by 0.82 and CR2 is 184.81 divided by 0.82, so many meter per second. CR1 turns out to be 225.38 meters per second. Are you there? Now this is not asked in the problem, but anyway we need to find what is CR1. So this is one part. Now we know CR1 and beta 1 it is equal to beta 2, so this inclination also we know. Right? We know this vector in the inlet velocity triangle and its inclination beta 1 is also known. So if you see this inlet velocity triangle, CR1 is known and beta 1 is known. So one vector is completely known. We can find the other yellow vector in the inlet velocity triangle, which is CA1 and its inclination is alpha 1. Are you there? So the idea of the problem is CA2 and alpha 2 is given. In the exit orange velocity triangle, one vector is given. The other orange vector can be found from trigonometry. Then from this one orange vector, one of these yellow vectors have to be found. This yellow vector is easy to find because CR2 and CR1 are related. And we also know beta 1 is equal to beta 2. So this yellow vector, the magnitude and direction are given. You can find it from one yellow vector in the same velocity triangle. The other yellow vector has to be found from trigonometry. Are you there? That's what we are going to find. From CR1 and beta 1, we are going to find CA1 and alpha 1. They belong to the same family, the inlet velocity triangle family. If you see the inlet velocity triangle, now focus on CA1 because that's what we are going to find. CA1 has a horizontal and vertical component. The horizontal component is what I call it as CW1. The vertical component is nothing but CF1. Now if you come with me to the figure, this yellow line is CA1. Its horizontal component is this whole thing, which is made of a white part plus a pink part. The white part is U and the pink part is the horizontal component of CR1. Are you there? So the horizontal component of CR1 is CR1 cos beta 1. Are you with me? So this plus U will give me CW1. So CW1 is nothing but U plus the horizontal component of CR1, which is CR1 cos beta 1. Okay, from the figure. Now CF1, if you see in the figure, CF1 is same as the vertical component of CR1. So CF1 is nothing but CR1 sin beta 1 because it is same as the vertical component of CR1. Now you know U, you know CR1, you know beta 1. You know CR1, you know beta 1. So the horizontal component and vertical component can be found. Once this is found, this angle is nothing but alpha 1. So from trigonometry, these two lengths are known. You can find the hypotenuse using Pythagoras theorem and this angle from tan alpha. So now I write CA1. CA1 is square root of this square plus that square. This length from the figure is U plus CR1 cos beta 1. So U plus CR1 cos beta 1 whole square plus CF1, which is CR1 sin beta 1 square. And if you substitute and simplify, this is U plus, it is 150 plus CR1 is 225.38 cos beta 1 26.934 whole square plus CR1 225.38 sine 26.934 the whole square. Under root of this, you find this will be CA1, and this is something that you have to find in the problem. CA1 is equal to 364.94 meters per second. Now once you know CA1, then you can find what is alpha 1 from trigonometry. So from that triangle, tan alpha 1 will be equal to tan alpha 1 is opposite by adjacent. Opposite is CR1 sin beta 1. Adjacent is U plus CR1 cos beta 1. Now this is equal to, you can simplify and directly write the formula answer for alpha 1. Alpha 1 is 15 degrees 54 minutes. Okay. Right. Now all these data are found. We found alpha 1, we found CA1. What is the last one? The axial thrust or the axial force Fa. The formula is m dot into Cf1 minus Cf2. Okay. Now m dot is given in the problem. Cf2 we had already found in that problem, in that step, and Cf1 is nothing but Cr1 sin beta 1. So I just substitute directly. M dot is 2.5. Cf1 is Cr1 sin beta 1. So 225.38 sin 26.934 minus CF2. CF2 we had already found in the problem. It is nothing but Ca2 sin alpha 2. So 80 sin 80, 85 sin 80. If you do this, you will get the answer in newtons. 41.9